Whale tracks on land hint at walking ancestors before ocean adaptation. These aren't just any animal prints. They belong to ancient whales with limbs, animals that once roamed coastal areas millions of years ago, before evolving into the fully aquatic giants we know today. These ancient ancestors of today's majestic sea creatures once walked on 4 legs on land millions of years ago, marking a remarkable evolutionary shift. First up, how did walking whales look? Picture an animal about the size of a rhinoceros, with 4 sturdy legs ending in hooves and a long snout reminiscent of a crocodile's. The front legs were shorter than the back ones, giving them a slightly hunched posture. Their bodies were covered in rough skin, more akin to that of a lizard than today's smooth-skinned whales. But wait, there's more. These early whales had massive tails, with 5 digits on each flipper. They weren't fully adapted for life in the water yet. They still needed solid ground under their feet. The tracks show clear evidence of 4-legged locomotion and even some dragging of limbs, hinting at a creature that was both awkward and oddly graceful. Now, why did these whales leave land behind? It all started around 50 million years ago with climate change that transformed coastal environments into ideal habitats for early marine life. These early whales, known as protocetids, were semi-aquatic creatures thriving in shallow waters where they could still breathe air and bask on beaches, marking a pivotal transition from land to sea. But the real question is, how did these land-dwelling animals become fully aquatic? That's a journey of millions of years, filled with gradual changes. Their nostrils began shifting to the top of their heads, becoming blowholes for efficient breathing at the water's surface. Limbs slowly shortened and evolved into flippers, perfectly adapted for swimming. Additionally, tails grew longer and stronger, developing horizontal flukes for powerful propulsion through water. But here's where it gets wild. These whales didn't just swim, they could still walk on land too. Protocetids were like amphibious superheroes, with flexible spines that allowed them to move both on land and in water, making them incredibly versatile creatures. Imagine a creature capable of hunting fish in the sea during the day and resting on warm beaches at night, perfectly adapting to their semi-aquatic lifestyle during the Eocene epoch. What's even more fascinating is the versatility of their diet. These early whales weren't just fish eaters, they were omnivores, capable of feeding on both plants and small prey in coastal areas. This dietary flexibility allowed them to adapt rapidly to changing environments, giving them a significant evolutionary advantage over other species. Now let's zoom in on one of the most incredible species, Ambulocetus natans. It means swimming and walking whale. Imagine a creature about the size of a large bear, with powerful hind legs and shorter forelegs, equipped with webbed feet that made it an efficient swimmer in shallow seas around 50 million years ago. Its jaws were filled with sharp teeth designed for catching fish, not crushing plants. But here's where things get truly bizarre. Ambulocetus had ears that were uniquely adapted compared to other whales or mammals of its time. Its ear structure allowed it to hear underwater without lifting its head out of the water, which was a critical adaptation for diving deeper and staying submerged longer in search of prey. Now let's talk about Pachycetus, another early ancestor. This one is like an odd mix between a wolf and a small horse. Imagine standing next to it. It would look like a large dog with hooves instead of paws. Its long snout was filled with sharp teeth perfect for catching fish. Additionally, robust bones in its legs suggest it was still quite capable of moving on land, bridging the gap between terrestrial mammals and fully aquatic whales. But here's the kicker. Pachycetus likely spent much of its time in shallow coastal or nearshore environments, hunting and resting. Its diet was versatile, allowing it to consume both aquatic and terrestrial prey. This adaptability enabled Pachycetus to thrive in a rapidly evolving ecosystem. Now let's fast forward to the next stage in whale evolution, Basilosaurus. Picture an animal about 60 feet long, roughly as big as 2 school buses lined up side by side. These whales had already significantly reduced their hind limbs, retaining only tiny remnants that were more like vestigial appendages than functional legs. Their front flippers were much larger and more developed, making them powerful swimmers capable of rapid underwater maneuvers. But here's the thing. Basilosaurus had hind legs too small to support its enormous body weight on land. Instead, it relied solely on its tail for movement through water, marking a significant evolutionary transition from an animal capable of both walking and swimming to one fully adapted to life in the sea. And then there's Dorudon atrox, a smaller cousin of Basilosaurus, but just as fascinating. Picture an animal about 12 feet long, with sleek flippers and a powerful tail adapted for swimming. Its teeth were specialized for crushing shellfish, making it an expert in shallow marine environments where such prey was abundant. Dorudon's ancestors once walked on 4 legs before adapting to life in the water during the late Eocene epoch. But the real mind-bender is this. Dorudon's skull shows clear adaptations for deep diving, such as expanded sinuses and a streamlined body shape, allowing it to dive deeper and remain underwater longer than its ancestors. These features enabled Dorudon to exploit new food resources in the ocean depths, marking a significant evolutionary step in its transition from land to sea. Now let's talk about one of the most recent walking whales, Crocodile-like minimus. Imagine an animal roughly the size of a large seal with feet, adapted for both swimming and walking. Its teeth were specialized for catching fish in shallow waters, but its limbs were still robust enough to support its weight on land. While not possessing hooves like some early whale ancestors, Crocodile had functional feet that helped it navigate between water and shore environments. But here's where things get interesting. Crocodile had flexible ribs that enabled its lungs to expand more effectively for breathing at the surface and underwater, allowing it to dive deeper and stay submerged longer than many of its contemporaries. This flexibility also provided it with the ability to move both efficiently in water and on land, bridging the gap between terrestrial ancestors and fully aquatic descendants. So, what does this all mean? The story of walking whales is one of incredible adaptability. These creatures began as fully terrestrial animals and gradually adapted to an aquatic lifestyle, evolving into the ocean giants we know today. It's a testament to how life finds ways to survive and thrive in changing environmental conditions. Now, let's recap. From protocetids with 4 sturdy legs to Basilosaurus with vestigial hind limbs, each stage of evolution brought new adaptations that allowed whales to explore deeper waters and hunt more efficiently. But the real kicker is this. Every single one of these ancient whales demonstrated remarkable versatility in their ability to move both on land and in water, showcasing a transitional period where they could still navigate terrestrial environments while becoming increasingly adapted for aquatic life. Imagine creatures that once roamed on 4 legs, later evolved to swim gracefully using powerful tails, and eventually became adept at diving deep into oceanic realms. This transformation over millions of years is a testament to the incredible adaptability of life. These animals, known as early cetaceans like Ambulocetus and Pachycetus, transitioned from land-dwelling ancestors to fully aquatic descendants, showcasing nature's remarkable ability to reshape species. But there's one final twist. These whales didn't just evolve, they thrived alongside other marine creatures for millions of years. Imagine an ecosystem teeming with diverse species, each adapting and evolving together in this ancient aquatic realm. So here's the big question. What does this tell us about our own future? If nature can transform a land-dwelling mammal into a fully aquatic giant over millions of years, then anything seems possible given enough time and environmental change. It's a powerful reminder of life's adaptability, highlighting how species evolve in response to changing environments. This should make you think twice before assuming we know all there's to know about the natural world. So next time you're walking along a beach and see some tracks in the sand, remember, they might not just be from any ordinary animal. They could be evidence of an incredible evolutionary journey. Whales once walked on 4 legs. This transformation marks one of the most significant shifts in marine mammal evolution, revealing how these creatures transitioned from land-dwelling ancestors to fully aquatic giants. Think about those tracks again. They remind us of nature's endless capacity to surprise us, evoking images of ancient whales like Ambulocetus that walked on 4 legs. Imagine standing there on that same beach, looking at those tracks and realizing they could have been made by a creature as massive as a modern-day blue whale. It's mind-boggling to think about an animal that big once dragging its body across the sand during the transition from land to sea. These ancient whales had powerful hind limbs that helped them move around on land, as well as strong flippers for swimming in water. Their bones were thick and dense, acting like ballast to keep them stable in deep waters, much like how a scuba diver uses weights. Additionally, these bones were reinforced with extra bone tissue, making them exceptionally sturdy and capable of supporting their weight both on land and in water. One of the most fascinating parts is that these early whales had flexible hips. Their pelvises were connected to their vertebral column and rib cage by strong ligaments and muscles, giving them a surprising range of motion. This allowed them to support their weight on land, while still being able to swim like modern whales do today. It's as if nature provided them with the best of both worlds, enabling these amphibious creatures to navigate between terrestrial and aquatic environments with remarkable ease. Another mind-blowing detail is that these transitional whales had snouts brimming with sensory hairs, which helped them navigate murky waters and detect prey. These whiskers were highly sensitive, much like a cat's but far more advanced, allowing them to feel vibrations and changes in water pressure. This heightened sensitivity enabled the whale to hunt effectively even when visibility was poor, giving it an evolutionary advantage in its aquatic environment. But here's where it gets really wild. Some of these ancient whales exhibited both filter feeding and predatory adaptations. Certain species possessed baleen-like structures in their mouths, similar to those found in modern blue whales, which they used to strain tiny crustaceans from the water. Yet other species retained sharp teeth for capturing fish or squid, indicating a diverse diet that allowed them to adapt to various marine environments. These whales also exhibited incredible social behaviors. Fossil evidence suggests they lived and traveled in large groups, much like modern-day dolphins do. They likely communicated through clicks, whistles, and songs, using sound waves to locate each other across vast distances. This level of sophistication hints at complex social structures that help them adapt to life both on land and in the water during their evolutionary transition from terrestrial animals to fully aquatic creatures. Imagine the remarkable transition these whales underwent, evolving from quadrupedal landwalkers to the magnificent marine giants we know and admire today. This transformation represents one of the most incredible evolutionary journeys in the animal kingdom.